You're listening to Impulse to Innovation. The Institution of Mechanical Engineers podcast. I'm your host, Dr. Helen Mees. As a global community of mechanical engineers with over 120,000 members in 140 countries, the Institution of Mechanical Engineers has been at the heart of the engineering profession since 1847. The institution's mission is to improve the world through engineering by sharing the latest news, views and insight into the creative world of technology and the people that make it happen. While the IMechE is recognised as a charitable organisation, you may not be aware that it does own a number of businesses. These wholly owned subsidiaries have been acquired by the institution over many years and specialise in learning and development, providing training and expert knowledge to engineers all over the world. One of these businesses is IMechE Argyll Ruane, a world-renowned non-destructive testing, corrosion and coatings training and consultancy based at the heart of Yorkshire steel industry, Sheffield. Non-destructive testing is an invaluable tool which enables engineers to look inside materials to find out if they have defects not visible to the naked eye. In this month's episode, I spoke with two of IAR's training team to find out more about the role they play in providing this invaluable service to the engineering community and what is involved in the training itself. The Institution of Mechanical Engineers acquired Argylle Ruan in 2012, but the company itself has been serving the engineering community since 1985. During its 30-odd years, Argylle Ruan has certified thousands of engineers in different aspects of NDT, corrosion and coating examination and testing, and has issued over 15,000 qualification certificates. The IMechE Argylle Ruan Engineering Training Centre opened its doors in August 2015 at the Sheffield Business Park, where some of the world's leading engineering organisations are also based. The training team, led by General Manager Chris Kirby, are a highly skilled group of engineers with over 150 years of engineering experience between them. But they are also extremely proud to be passing that knowledge on to the next generation of engineers and have several apprentices working in the team who hope to carry on Argylle Ruan's impressive traditions. My first guest is trainer Christian Beaver. Christian joined IAR as an NDT apprentice and completed a 3-year NDT Engineering Technician Apprenticeship in August 2021. He is now fully qualified to teach students in personnel certification for non-destructive testing Level 2, which includes magnetic and penetrant testing, ultrasonic testing of wells, nozzles, nodes and tees. I began by asking Christian, where did the name Argylle Ruan actually come from? Christian, thank you so much for joining me on the podcast today. I'm really pleased to have you on. So where does the name Argylle Ruan come from?
It's long before my time. I believe Ruane was the name of someone that created or started the company. I would have to double check this, but I believe that's where it comes from. And I believe that Argyle was a name chosen when obviously the phone books were around, so that they were near the beginning. Obviously,
Right.
That would be something that would be worth double checking. But I'm 90% sure that's what it was. Is that Ruane started here, and then Argyle was chose because it was just closer to the front of the alphabet for the phone books.
I think even if that is just an urban legend, I think that is what we should just go with.
Oh, it's a very good story.
Let's just say that's actually the real story.
Yeah,
I think that's great.
We'll just change it anyway. If it wasn't that, we'll do it now. That's it.
So can you tell us a little bit about your engineering journey and how you came to have a career in non-destructive testing?
Yeah, of course I can. So my sort of engineering journey started off when I did my A-levels at college. I did maths, physics, economics, and I did an AS in chemistry. And throughout my A-levels, I always wanted to go into some form of engineering. And sort of at the end of those A-levels, the choice was between a university and trying to get a degree that way, or trying to go into that apprenticeship route. And I was one of the few people that decided to go in that way. But like I said, all the way through even my GCSEs and my A levels, I want to do some form of engineering.
So, how did you end up doing non-destructive testing? Because that's quite a specialist route, right?
It most certainly is. It's as simple as I have an older brother that also by chance ended up in non-destructive testing when he was younger.
Right.
And throughout all of this, it was sort of considered. He's sort of more a hands-on sort of person, as I'm a bit more academic. But then when this sort of job here came up, which is a bit of both, a bit of engineering, a bit of teaching, that was ideal because teaching was also something I had considered during my A levels. So that's sort of how I knew about NDT. But like I said, being from sort of Sheffield and the local area being engineering, when I was doing my A levels as well, I think there was only 3 or 4 of us that didn't go into university, and by chance 3 of us all ended up in NDT anyway. So it's
right.
The local area breeds engineering anyway, I think.
Well, I am a Sheffield girl, despite having lost my Yorkshire accent a little bit because I've lived in Leicestershire for a long time now. But my dad worked in the pits, so that community of engineers, that sort of every family member was an engineer or some kind of related to some of the heavy engineering or manufacturing in and around Sheffield for me. So yeah, it was a big influence for me too. So Christian, you did a 3-year NDT apprenticeship, didn't you? So what was it that made you choose that kind of route to go down? And, what's the difference between the kind of the apprenticeship offerings that you could have possibly taken? And what aspect of the course did you enjoy the most?
So I believe sort of the first decision when choosing apprenticeship over university was I was looking at a lot of friends and stuff who were slightly older that had done university, and older people that have spent the years there, got the degrees and come out of that not really knowing what to do at the end of it, having no real experience in the work they're doing as well other than theoretical. So when choosing the apprenticeship, I wanted something where not only did I learn the theory and all of that stuff behind it, but I was able to at least see and do what I'm doing. Like you say, if you have older family members in certain industries, you hear a lot of the time them saying about people coming into jobs, having the qualifications, but not knowing what they're doing. So I thought an apprenticeship would be a better way to try and gain that experience. As you said, there's multiple different types. So I did an apprenticeship through Skills Training UK, who help apprentices go through an apprenticeship scheme in non-destructive testing. I did the level 3 apprenticeship, which is the NDT Engineering Technician. That gave me 3 level 2 NDT qualifications, as well as an NVQ in business improvement techniques. So that's what I went for. They do a level 2 apprenticeship, which is, I believe, just 1 NDT qualification, and they do a level 6 apprenticeship, which is the NDT Engineer, which I believe is degree based. So they go and do the degrees through that. Biggest challenge through that, as someone who hasn't really worked, obviously a lot in industry, coming in as apprenticeship straight through, would probably be the business improvement sort of techniques part of it, in that you have to find sort of parts of the business that aren't sort of optimal and try and improve those. But when you don't have the most experience, it's quite a struggle. It's very good and you learn a lot from it, but just trying to improve certain aspects was quite a challenge through that.
Yeah, I must admit, looking back over my career, I wish I had that opportunity to do an apprenticeship myself. Mine was very much, as you said at the beginning, kind of forced down the A-level route, which was really not for me. I'm a very hands-on kind of practical person and learn much better that way than sitting exams. So it sounds like it was a really enjoyable time for you. What aspect of it did you enjoy the most?
To be honest, I think the people, especially here in this business where we teach a lot of people from industry and they come in and they share stories and stuff like that, as well as the experience I gained here, I got to learn from a lot of people from, I guess, the same industry, but different aspects of that.
Yeah.
And we have sort of many different people working here that have different experiences. So you not only learn what's necessary, but you get to learn extra bits that are interesting and very useful throughout that. And I like that aspect of speaking to people and learning the differences and what they do and all that sort of stuff. So that's probably what I enjoy most. about being here.
Yeah, I enjoy the teaching side of what I do as well, and it is really nice. You learn so much, don't you, from other people's experiences and sort of anecdotes that you can kind of build your own experiences from, which is really quite cool.
Yeah, fully agree. Like I say, I'm by no means think that I know everything. In fact, I know very little compared to a lot of people that come in here, like I say, experience-wise, as much as I'm teaching them. But there'll be people in here that have been doing non-destructive testing for longer than I've been alive, and I don't say that jokingly. I do have that quite often. So that you get a nice sort of rapport there in that you're helping them, but then they're also speaking to you and on all that sort of stuff, and you'd learn a lot through most of those. Yeah.
Well, that kind of leads me nicely onto my next question, really, because obviously doing an apprenticeship, you're obviously doing the studying, the classroom work, and you're also, on the job doing the actual physical work as well. So what do you think were the most valuable lessons you kind of learnt during that time, and how does that relate to what you're doing today?
The most valuable lessons during that were going on site and doing actual non-destructive testing. I say actual non-destructive testing because we do that here, but because it's a classroom environment, it's a lot of classrooms. The sort of materials we work with are a lot nicer to work with, so it's not as sort of nitty-gritty as sort of on-site working. So to be able to go out on site for a few months doing actual NDT work to gain that experience to help me then teach when I come back here in the future was probably the most useful and very enjoyable. However, most NDT apprenticeships are less based like that. They work at an NDT company and do that from them. For those, the most enjoyable part, well, obviously I can't fully speak for them, but like I said, I did very much enjoy the business improvement. And I guess especially when you're younger, it's something you might not think too much about.
Yeah.
But as you start getting older or you start working longer, you look at things that you want to change. And rather than just moan about it, you get up and you can actually go and change them and make changes to that. And it actually makes your life a lot easier further down the line.
It must be really great to see lots of new apprentices coming through like you did. So what does your job involve today as an NDT trainer, and how important is it to provide training not just to the NDT community but to the engineering profession as a whole?
So yeah, my job involves training up NDT sort of operators, and whether they be apprentices or sort of anyone coming into the industry, up to a sort of qualification of a level 2 in NDT. And I teach 3 subjects. One is PT or dye penetrant. Just briefly, you paint some dye on a surface, it gets sucked in for during reasons into defects. You then spray what's called a developer on there, and that brings the penetrant out, and you can see a nice line where the defect is. That's one of them. I do MPI, which is magnetic particle inspection, which involves inducing a magnetic field into a magnetic material, and wherever there are breaks in the material there, you get what's called a flux leakage that attracts small sort of particles to that area, so you can see that area there of cracks, and they have to be surface breaking. The last one I do is ultrasonic testing, which is sort of one of the earlier forms of sort of like baby scans, where you go for an ultrasound. There are sort of more complicated methods which do put a nice image up on the screen for you, but that one's a bit more complicated, but it involves sending sound through a material. So those are the 3 sort of that I teach, and I do get sort of quite a few apprentices coming through. All, well, most very young, most very eager. We've had one in the past couple of weeks, only 16, come straight out of school. Just pure effort. It's just, that's all you see from them. But the job is teaching them both the theoretical of how things work aspects of the job, as well as showing them how to be able to test materials, to be able to find defects over the course of sort of a week for MPI and dye pen, and it's a 3-week course for ultrasonics, and to be able to get them to be able to then go out on site and be able to test things. As for how important it is, if we have no training, there are no qualified operators and there is no non-destructive testing. And non-destructive testing is one of those things that most people never think about and you don't hear about, but it's used on everything from cars to planes to bridges. It's just checking that things aren't broken before they get put in. So if there's no non-destructive testing, you can have cracked bridges, faulty planes, faulty car parts, anything. It's one of those things that is very important. We just don't think about it day to day.
Yeah, I must admit, in my career as an engineer, I have used NDT testing on many occasions, whether that's actually going to people like yourself who are experts who can do it for me, or actually I had a go with a dye penetrant many years ago. And it's absolutely invaluable to problem solving, isn't it? To understanding what failures may have occurred or may occur. And that's a really fundamental part of what we do as engineers, I suppose, isn't it?
Yeah, like you say, especially on the engineering part of it, for that working out what's gone wrong. So there's the testing stuff that's in service and just seeing if it's broken. But there is, like you say, if you work at a forge or a foundry and you keep testing the same part and the same things going wrong with it, what can we then do to fix that, or what problems are occurring to try and solve that? And like I say, for an engineering point of view, that's probably the most invaluable, because it means you can stop the problem before it starts if you can figure it out the first
absolutely.
time.
So I know you're still very much in your early career, but looking back on your career so far, what advice would you give to a young person, a young self, or even to anyone really who's considering maybe a career change to come into a career like NDT?
My advice for young people, especially ones finishing their GCSEs that aren't sure what they do, is just to look into apprenticeships. See what's around you, see what's there. I go backwards and forwards constantly on whether I should have done my A-levels or should have looked for an apprenticeship beforehand, because as much as I enjoyed my A-levels and stuff, I don't massively use them. They help for what I'm doing here, but an apprenticeship sort of gets your foot in the door that much earlier. You gain the experience, you sort of know what's happening, and you will be qualified and working to a decent level before most people have finished their A-levels or especially degrees and stuff like that. And like I say, I have lots of friends that are at university now that have done degrees and stuff like that and have finished, and they go, well, what now? Because they're still not sure. It's just everyone sort of gets pushed into that A-levels route and then to that degree route, and no one really talks about apprenticeships very much, which is something that does irk me slightly, because I can't recommend apprenticeships enough for young people. As for NDT specifically, like I say, young people wanting to get into NDT specifically, Skills Training UK, you speak to those, either they will sort of find a business near you, or if you've got a business in mind, and they'll try and set up an apprenticeship scheme with them, and you do all your practical sides at work, and they come in and do all the theoretical and all that sort of stuff. And it's amazingly organised for apprentices to come through and go through that route to be able to get those qualifications.
I'll make sure we put those links up that you mentioned there to those apprenticeship sites, so our listeners can have a look and see what it's all about, and also to some of the IMechE's links on apprenticeships. So one final question for you. Are you taking a chartered route to become an Eng Tech, or are you already an Eng Tech?
I will be going towards that route at some point. I'm wanting to focus more on my job now, get that nailed down.
Yeah.
And then once that sort of becomes fully second nature, we can go on to sort of a degree level sort of route there. Sort of I'm classed as an engineering sort of technician, but I would like to take that further throughout that. Like I said, the apprenticeship I did was the engineering technician sort of route, but I know Skills offer a degree level one, which is based in NDT, and I will hopefully do that in the future.
Well, we wish you all the luck in the future, and when you've got that, maybe you can come back on the show and tell us a little bit more about that route that you went through to get your Eng Tech. Christian, thank you so much for joining me on the show today. It's been really fascinating to hear not only about NDT itself, but your journey through the apprenticeship route. So thanks very much for sharing that with us.
Oh, thank you very much for having me. It's been very enjoyable.
My second guest is Mick Mullins. Mick is a Level 3 consultant at IAR and has over 40 years' experience in non-destructive testing. His knowledge spans across a multitude of testing methods, including magnetic particle, penetrant testing, visual and ultrasonic testing, phase array and time of flight diffraction. Mick also holds a BSc in non-destructive testing. His role involves supporting clients to ensure their NDT departments are compliant with industry standards. I asked Mick what got him interested in NDT. Mick, thank you so much for joining me today on the podcast. I'm really pleased that you've been able to join me. Now, before we get into the nitty-gritty of NDT analysis, let's talk a bit about your journey. What led you into a career in NDT, and what do you most enjoy about the role that you do now?
I got into NDT by accident. The company that I was working at the time, I worked on machines. They didn't have enough work on the machines, and they asked me if I wanted to try on inspection at the time, and then went into there to fill in. And then the foreman there asked me if I were interested in NDT, and I suppose the rest is history.
So it was you kind of fell into it really by accident.
Yeah, and I think most people, if you ask them of my age, will probably say exactly the same, because when you're at school, they didn't bring NDT. You didn't really know what NDT was at the time. It's only as years have progressed on that we've actually brought it more to the forefront, shall we say. And I think it does get mentioned in schools now. I've certainly been in a few schools to do some demonstrations and things like that. So, yeah.
Well, I must admit, it wasn't something even that I came across until I got into industry. You know, I'd never really heard of it at university as such, and certainly never done it. I did a little bit of work in my job when I was in industry, but that was the first time I'd ever come across it. So it's really interesting to hear that you kind of fell into it as well. Now, in my introduction to today's show, I've talked a little bit about Argylle Ruan, its history, and when it became part of the IMechE's corporate arm. But can you tell our listeners a bit more about the type of work that IAR do and the various types of NDT testing?
It's split up into three sections. There's a level 3 services, which is the department I work for. And then we have training and exams. And then we have another one called ICO, which is like paint inspection.
Right.
If we look at overall, what I presume most of the listeners will be aware of is our training. Now, we do training on probably the main 5 or 6 methods in NDT, which is magnetic particles testing, penetrant testing, visual testing, ultrasonic testing, radiography, and eddy current. So they're the main 5 or 6 methods that Argylle Ruanes teach. There are other methods, but we don't really get involved in any of them as such.
Right.
And other than that, that's probably what most of the listeners will be familiar what we do.
I remember doing the paint. And having a go at that and then cleaning it off and seeing where the cracks were in metal and stuff.
That's the penetrant.
Yeah. But the ultrasonic side of things, it's quite advanced, really, isn't it? It's quite a useful tool, though, in engineering.
It is. Ultrasonics is, I think it started way back in the probably 40s or something like that. But that side of it, that what we call manual ultrasonics, hasn't really changed a great deal, other than that the electronics has brought it more up to date. And the newer techniques within ultrasonics, like phased array and TOFT, they are able to put the scans together to create pictures. So if I can liken it to like if you go to hospitals and you have an ultrasound and things like that, you see the picture.
Yeah.
Well, it's exactly the same as that. What we do on metals, and it's actually the same principles that's filtered down from the medical industry into NDT. So it's them that what we use.
That's really fascinating, because I work in that biomedical community these days, and so I can kind of imagine in my head how that might look, how that imagery might look, and it can make a big difference, can't it, to being able to see through layers of say a machine or an object, to be able to see what's going on inside.
It definitely does, definitely, and then it gives you more confidence because previously in the ultrasonic operators will be able to liken it to it that when you're scanning something manually, as we call it, you're looking on a trace on a screen and you're having to decipher what the signal is as to regards what type of defect it could or could not be. But when you get these new advanced systems, they put all that together and give you certainly it's a 2D picture, and the more modern and expensive ones can give you the 3D picture where you can maneuver it and look round things. And yeah, it's fascinating. It really is.
So, what is your typical sort of day-to-day role then? I know that you have driven all the way down from Scotland over the last 24 hours and you've been delivering training up there. But what's your sort of typical role and what do you enjoy most about what you do?
It's very varied as roles, I suppose. This week I've run a course for. We've got a new centre opened up in Scotland.
Yeah.
And I've actually run a visual testing course for, I think there was 8 on it, and they're having their exams today.
Right.
And I've taught the course Monday to Thursday type thing. I probably don't run that many courses as such. I'm more with the level 3 services. In that we go out to customers to advise them on, so say they have to work to some standards for an order that they've won, and that might involve NDT. And as part of some of the standards, they have to employ what they call a level 3 NDT.
Oh, I see.
And because that can become quite expensive to solely employ it at that company, and there's probably not enough work for the person to be there. What we do, we offer a service that they can employ us to fulfil that part of the standard,
Right.
And we go in and guide them. And initially, I dare say we probably spend a few days at that company to get things right, and then periodically or over the couple of months or so, we pop in from time to time to make sure it was all running okay, that type of thing. So that type of work, I probably got 20 to 22 customers that I have to do that on quite a regular basis.
Right.
We do what we call surveillances on operators, and that's part of the company that I work for. Do a lot of work for the American Navy.
Right.
And the standards that they work to is that they have to have performance demonstrations done, and we go in and verify them, that type of thing. And it is quite varied, to be fair. It's hard to put words to something that I do when, if I sat back and thought about it, I thought, oh yeah, there's this, and this. But
Yeah.
it just when you're on the spot, it's quite difficult sometimes.
Yeah, I mean, it sounds like what you do, you really love. But
Definitely.
the work that you're doing is kind of, that role is kind of a consultancy role almost, and an auditing kind of role as well. Would that be fair to say?
Exactly that. Yeah, he says we act as consultants for the company that employs to be their level 3s. Yeah.
So, the training that you've gone through then over the years to get to that level of expertise, that must have been quite a lot of, work that you've had to do to develop that knowledge and be able to retain it so that you can go out and advise customers.
That's true, I suppose. As regards experience-wise, I've been in the industry many years. I dread to think, when did I get into it? Into the late 80s when I first started.
Right.
And as to become a level 3, you just don't become it. You have to, how can I say? You have like a path to follow. You have to get various levels, and there's various NDT level 3 qualifications as well. So I guess I've gained them probably over. I would guess over a 10-year period to get to where. Then you have to keep on top of them. Then like re-examining. We have to go to various places to keep them in certification. That type of thing.
Yeah, I was going to ask you that. How do you then go about maintaining your standard? Because obviously, as engineers, we have to maintain our professional development, don't we?
Yeah.
And we do that
right.
continually through our working lives. But you must then be having to learn new standards and new regulations that are coming in. Do you go through a process of that over a period of time?
We do. We have like 5-year periods for each individual method, and what happens is at the end of that 5-year period, we go to another NDT school. We can't go to a Selden, unfortunately.
Yeah.
We have to go to another one, and we just sit at another exam to keep it rolling type
Yeah.
thing. The exam would ideally be set up that if there's any changes in them standards, them common standards for that method, it would be encompassed into that exam type thing.
Yeah, absolutely. Now, obviously, the majority of industries that you work in and probably are the most familiar, I suppose, with testing and NDT is the oil and gas industry, the car industry, aerospace. How is NDT developing? Are other industries starting to adopt the methodologies to be able to look at problems within pieces of equipment that they might be building or so on? And what sort of changes are you seeing in the industry going forward?
Well, you're right in saying that we do work with aerospace companies. We do a lot of oil and gas work, petrochemicals, power plants, things like that. But I would imagine if you're talking about new types of work coming in, well, I'm on a working group at the moment that's looking at composites for certifying them. Although they do use a lot of the technology that we use on metals, the one that I'm looking at the moment is for marine. And it's to test that the yachts are still, sound and worthy and things like that.
Yeah, the nature of composite materials is such that it's not as homogeneous, I suppose, as a piece of metal, is it? So
It isn't.
I'm guessing you're having to change the way that you work and the way that you understand the material to try and identify where failure points might be.
It is, and I think the thing that we're looking at more often is obviously newly manufactured composites, but it's also the next step would be, or in fact, it is being done, is to look at how if they get damaged, because that damage presents itself in a different way to what it would do in the steel or metals, which we're commonly familiar with. So, and it's getting to understand how that presents itself when it might not be the techniques and the methods that we use for metals. It might not be applicable, or it displays itself differently in composite type materials. Say you've got something that's had some impact damage on composites, it'll spring back to its normal shape and you won't know. So the layers underneath it, you're not going to know if they've been damaged or structurally unsound or things on that nature. As regards with a metal, you'd see that there would be a big dent in it, so it'd give you an idea. So you'd be looking for, like, I suppose, bruising and things like that on it.
Yes, I suppose with a composite material, something that's fibrous, it's not going to be a definitive crack, is it? You're going to get it spreading through the material and through the layers.
Yeah. Mm-hmm,
yeah. Mm-hmm. So I'm guessing, coming back to what we were saying about your continuous learning and developing, that's a whole new sphere for you and the team to have to, study yourselves to get confident in it.
It is, yeah. Yeah, it is. It's for the company as well itself. It is a massive new step for us, and it's something that I think there's quite a few people who are looking forward to it and going to enjoy it as well. It keeps the grey matter in your mind ticking over, looking at new different ways in which the defects or sort of them type of things present themselves.
Yeah,
really.
I think that's what gets us passionate so much about engineering, isn't it?
It is. Yeah,
is the next big challenge. How are we going to solve? And today, while we're recording, today is World Engineering Day, so it's quite nice to be talking about that passion that we have for solving problems and understanding. I've always had a fascination for why things break. So it's really nice to hear just, how much you're doing to kind of learn and develop your knowledge to be able to pass that on to other engineers, to make sure that we can keep, the world running, as it were.
Right, yeah, keeping it safe.
Well, Mick, thank you so much for taking the time to talk to me today. It's taken me back to my early days as a young engineer and learning about all of these things. But also, I think what it shows is the lengths that engineers will go to solve problems and to ensure that we can keep the world ticking over and making sure that all of that technology continues to work and is effective. And we couldn't do that without what you guys do. So thank you so much for talking to me today.
No problem, Ellen. Thank you.
That's all for this month. In next month's show, we will be celebrating all things STEM learning. As I record today's show, it is World Engineering Day, But during March, we also celebrate British Science and Engineering Week, which is a wonderful opportunity for children to experience the amazing world of science and technology, how it changes their lives on a daily basis, and what amazing careers they too could have in the future. On the 24th of March, the IMechE is launching its fantastic new initiative, Elevating Engineering, which aims to focus on how engineers can respond to delivering the institution's mission to improve the world through engineering. The event, which will be attended by MP Amanda Soloway, Lord Commissioner of Her Majesty's Treasury and former Science Minister, and will see the unveiling of a brand new IMechE STEM Ambassador induction video and exciting new web resources. We will be speaking with Jelena Gassessa, who spearheaded the Elevating Engineering project, and we will be finding out more about the IMechE's education theme for 2022. You've been listening to Impulse to Innovation, the Institution of Mechanical Engineers podcast. Thanks for listening. We'd love to hear from you, so if you'd like to share any news or any feedback with us, then please email us podcast@imeche.org. All the information on this episode can be found in the episode notes.